Angela.
What's up, guys? What are you up to?
Oh, nothing. We're just working on our extra credit assignment for a human physiology class.
Ew, human physiology? I hated that class. I totally aced it, though, by not going to class. What's your topic?
We want to demonstrate the different types of reflexes and their association with the CNS.
Ah, the CNS, the Central Neurological Sciences.
No, Angela, the central nervous system. It's the complex of nerve tissues that controls the activities of the body. In vertebrates, it comprises the brain and spinal cord. Duh.
Geez, Angela, for someone who aced the class, how do you know nothing about the CNS?
It's not important. Anyways, do you guys want to take a break and play catch with me? I'm pretty sure I'm the best catch player ever.
I suppose we can take a short break.
Hey, let me in.
For sure, come on in.
Ouch!
Sorry about that, Angela.
Wow, Angela, you have poor reflexes.
Angela, I think we should test your reflexes for our extra credit assignment. Don't worry, though. It's all for science.
Indeed. Do you even remember what a reflex is?
This killer headache is preventing me from thinking. Stretching makes me think I'll stretch.
Well, a reflex is an action that is performed as a response to a stimulus and without conscious thought. Central receptors in your brain cause you to have a slow response because you didn't have the time to react or even sense any stimulus.
Well, maybe you should give me a better warning next time. Maybe my reflexes would have been quicker.
Let's test out a different visual and auditory cues as different stimuli to see which one will make you have quicker reflexes.
We already know that having no visual cue was a bad idea, considering that bloody eye. I'm going to wave this beanie as a visual cue so that we can see how long it takes you to reflex and catch it. I think it would take longer than having no cue at all.
Wow, I caught that one super fast. Why did I catch it so fast?
Well, visual reflexes use specialized cells that convert the visual stimuli into an electrical stimulus. The receptors that accept the stimulus are close to the brain and are integrated before you reflex.
I don't get it.
Well, it's pretty complicated. Light is converted into electrical energy by the photoreceptors of the retina. Signals pass through the bipolar neurons to the ganglion cells, whose axons form the optic nerve. Once action potentials leave ganglion cell bodies, they travel along the optic nerves to the CNS for further processing. The optic nerve enter the brain at the optic chiasm. Some nerve fibers from each eye cross to the other side of the brain for processing. Ganglion cells, called M cells, convey information about movement, and conversion from light to the cell becoming inactive relies on 6 steps.
6 steps?
Yeah, that's even way more complicated. Alright, so a photon hits retinol lodged in a protein called rhodopsin in your rods and cones. This causes retinol to change shape and change the shape of the rhodopsin protein. Rhodopsin is also attached to transducin, which now gets removed. If transducin is lucky, it bumps into a protein called phosphodiesterase. PDE likes having transducin stuck on it, and it starts chewing up a chemical called cGMP. Prior to this, lots of cGMP was floating around and binding to a sodium channel, which keeps the sodium channel open. Now, as the cGMP runs out, sodium channels close. Sodium moves through the sodium channel that was previously keeping the rods and cones active. Now, the sodium channels close and the cell becomes inactive. Somewhere in there, that's about 6 steps.
Wow. Intense.
This time, I'm going to call you and give you an auditory response before I throw the ball to you. Potassium!
I caught it! I feel like I reacted way faster to that than I did to the visual cue. How do sound reflexes work?
Well, sound reflexes require less step than visual cues. So the way this works is sounds are processed from information of both ears and in both sides of the brain. pathway includes sound waves entering the cochlea and being transformed into electrical signals, followed by sensory neurons and transferring this information to the brain. The localization of a sound source is an interactive task that requires simultaneous input from both ears. Unless sound is coming directly in front of a person, it will not reach both ears at the same time.
How cool. Is there a pathway involved? Are there tiny little yellow potassiums in my ear that are doing all this work?
Well, physiologically, sound waves will arrive at the pinnae located in the outer part of the ear and help the sound waves travel through the ear canal until the waves reach the tympanic membrane. The tympanic membrane will begin vibrating at the same frequency as the sound wave and be changed into mechanical energy. This will soon change into a pressure wave within the oval window of the cochlea and then alter the frequency of the fluids within it. The pressure waves will cause the hairs of the organ of Corti to wiggle and causes the channels within to open and close and elicit a final energy relay to the auditory nerve. Lastly, the hair cells will create their own action potential to have the signal reach the brain. And voila!
In layman's terms, auditory has less steps than visual, so it takes less time for your body to recognize a stimulus and react.
Oh.
Yes to science.
Well, that's just one part of the body's working system, but that's for another video and another extra credit opportunity.
Okay, well, thank you for showing me how my reflexes work. Is there any way I can improve them?
Yes. You can improve your reflexes by doing better physical exercise, like running in the woods and changing up your routine. Also, catching a rubber bouncy ball works like a dodgeball.
You can also improve your reflexes through mental exercise, such as playing first-person video games or watching martial arts techniques to improve your peripheral vision.
That sounds awesome. Thanks.
No problem. Now go and practice your reflexes before I hit you in the face again.
And don't forget to eat a banana to stay strong and healthy.